Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 31st, 2025, just 2 days ago. It demonstrates that a specialized 8 billion parameter model, called OpenForecaster 8B, can match the forecasting accuracy of much larger proprietary models by training on synthetic news data. The paper is titled, Scaling Open-Ended Reasoning to Predict the Future, and as we'll see later, the results for calibration and consistency are really impressive. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the complete workflow, starting with the data generation pipeline in the top panel. To create the training set, the authors feed news articles into DeepSeek v3 to synthesize raw questions, which are then filtered by Llama 4 Maverick to ensure quality, resulting in the OpenForesight dataset. The bottom left section then details the prediction system, where a QN8B model with retrieval capabilities undergoes reinforcement learning. Crucially, the reward function here balances answer correctness with the Breyer score, a metric that encourages the model to provide calibrated, honest probability estimates. This process leads to the results shown in the bottom right chart, where the green arrow tracks the model's dramatic improvement, matching much larger systems. Alright, Figure 1 just sketched the general setup, but Figure 2 details the specific recipe for synthesizing questions from news. On the left, the process begins with generation, where DeepSeek v3 reads a news article and proposes multiple potential forecasting questions. Next, the pipeline moves to validation and selection in the center. Here, Llama 4 Maverick reviews these candidates to ensure they follow the guidelines, and then picks the best one. Finally, on the right, the system performs a step called fixing leakage, which strips out any unintended hints to ensure the final question doesn't give the answer away. So, while Figure 2 showed the steps, Table 1 here quantifies exactly how much those filtering steps matter. On the left, the graph compares training performance across different data strategies. The red line shows that without filtering, accuracy actually declines because the model learns to cheat rather than forecast. In contrast, the green line shows that applying all filters allows the model to learn 3 times faster than just removing leakage alone. Then, the table on the right reveals the strictness of this pipeline. From nearly 750,000 initial questions, only about 7% survived the quality checks to reach the final training set. Okay, moving from quality to quantity, Figure 3 shows the impact of scaling the dataset size. These plots track performance from 100 up to 50,000 samples, displaying the Breyer score on the left and accuracy on the right. Notice how the green curve rises steadily, indicating that the 8 billion parameter model gets significantly smarter with more data. By the time it uses the full set, it catches up to the horizontal dashed lines, effectively matching massive baselines like DeepSeek R1. Well, Figure 3 established the scaling laws, and now Figure 6 presents the head-to-head showdown against much larger proprietary models. In the left chart, covering the OpenForesight test set, the vertical axis tracks the Breyer score, configured here so that higher values indicate better performance. The purple star marks OpenForecaster 8B. It rises to the very top, achieving a superior Breyer score compared to the massive GPTOSS 120B shown in red. Shifting to the Future X benchmark on the right, the purple star dominates again. It pushes to the far right of the graph, securing the highest accuracy among all models while maintaining strong calibration. So, while the previous figure focused on pure forecasting, Figure 7 demonstrates how this training generalizes to broader reasoning skills. On the left, the bar chart tracks calibration on external benchmarks like SimpleQA and MMLU Pro. The purple bars show that OpenForecaster consistently beats the blue baseline with a massive 91% jump on SimpleQA. This implies that forecasting training improves the model's ability to know what it doesn't know. The right chart confirms this with a calibration curve. While the blue line shows the original model is erratic and often overconfident, the purple line hugs the dashed diagonal, meaning its reported confidence matches its real accuracy. Wrapping up, 2 takeaways stand out. First, rigorous data synthesis allows a compact 8 billion parameter model to rival massive proprietary systems. Second, this training significantly improves calibration, helping the model better understand the limits of its own knowledge. This suggests that mastering uncertainty is crucial for the next generation of reasoning models. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.